Hey, Algebra 1, Algebra 2. We're continuing your notes that we started in class on the unit circle part 2. So we're using sine and cosine and tangent to figure out what those values are for these angles. Okay, we want to know what the values are for those angles. Okay, what we learned today was that there's 3 other ratios we can use, and they're called cosecant, secant, and cotangent. Now, these ratios are very similar to sine and cosine because they're the cousins, or they're kind of like the brothers or sisters to sine and cosine. And the way that relationship works is that for cosecant, cosecant is equal to sine, but then it's flipped. So we put sine under 1. So it's 1 over sine. And what that does is instead of sine equaling, or instead of cosecant equaling opposite over hypotenuse, because it flips sine, it becomes hypotenuse over opposite. And the same thing with secant is that it flips cosine, and now instead of adjacent over hypotenuse, now it's hypotenuse over adjacent. And then we get the same result with cotangent, which is typically opposite over adjacent. And opposite is more associated again with sine, because you see that we have sine in the top of our ratio for sine, or opposite for in the ratio for sine, and then adjacent in the ratio for cosine. So tangent is sine over cosine, but cotangent is the same thing flipped, cosine over sine. And again, instead of opposite over adjacent, adjacent over opposite. So the point is, these 3 are the same thing as the other ratios, but then flipped. Okay? Now, what about the signs of the trig ratios in each quadrant? Well, we have a little map for you to use to figure out what those are. And the first thing you want to write here is that sine, I know sine is our y values, and in quadrant 1, y values are always positive. Actually, let's use the right color. They're always red. I mean, always, not always red, they're always positive. Okay, zoom in a little bit. Okay, now for cosine, x values in this quadrant are also always positive. Okay. And then remember that tangent is, again, sine over cosine, so that's positive over positive, so that tangent is also plus. So what we say is that all ratios are positive. We say A. All ratios are positive in quadrant 1. Now in quadrant 2, over here, sine is, again, the y value, and above the x-axis, y is always positive, so that's still positive. But then cosine on this, in quadrant 2, on the left side of the y-axis, is going to be negative. And then tangent, again, is sine over cosine, so it's positive over negative, and positive divided by negative is a negative. So sine, the only one that is positive over here is sine. So what we say is that sine is always positive in this quadrant. Everything else is always negative. Okay, so sine is always positive, and here would be A stands for all. Okay, and then down here on the bottom left in the quadrant 3, sine is below the x-axis, so now and it's y, so now it's negative. And then cosine is also on the left side of the y-axis, so that's also negative. But remember, tangent is sine over cosine, or this negative over a negative, and 2 negatives make a positive. Okay, So that means that all tangents in this quadrant, no matter what angle or radian you're looking for the tangent of, it's going to be positive. Okay? Now in the last one, quadrant 4, sine is going to be again negative, and cosine is going to be positive over here because we're on the right side of the y-axis, and then that means that tangent negative over positive will be negative. And the only one that's positive over here is cosine. So now cosine. And what we say in math is that all students teach calculus, right? Because you guys are all going to teach calculus one day. All right? So now let's figure out, how do we figure out the rest of these? Well, okay, first of all, cotangent. Cotangent of 270. Well, cotangent is, again, tangent flipped, adjacent over opposite. And adjacent members are cosine, opposites are sine. So for 210, let's go over to our unit circle. 210 is here, and it's the adjacent, which is the x value, over the opposite. Sorry, over the opposite, which is our y value. Okay? And this is negative, so I know it's going to be positive. So it's going to be this divided by that. So let's do that. So rad 3 over 2 divided by 1 over 2. Okay, then remember we flip it, flip the sign. So now 2's cancel out, and then we just have rad 3. Now I promise you're not going to need to do this on every single one of them, and I'll show you why. Okay, and the next one, sine of 210. Well, sine of 210, well, sine is just the y value. So let's find 210 here, and then sine of 210 is negative 1/2 because it's the y value. So that's negative 1/2. Cosine of 150. Okay, let's see, that's going to be the x value, so that's negative rad 3 over 2. Negative rad 3 over 2. And now tangent of 225. Tangent of 225. Okay, well that means it's going to be the sine over the cosine, or y over x, and rad 2 over 2 divided by rad 2 over 2. Well, you're dividing the same number into itself, so that means it'll just be a 1. In other words, rad 2 divided by 2 divided by rad 2 over 2, and that just equals 1. Okay. So the next one I want to look at is number 13, cotangent of 120. Remember, cotangent, again, is the cosine over the sine. Cosine over sine. Okay, so cotangent of 120. Let's go to 120. 120 is right here. And it's going to be the cosine, which is our x, over our sine, rad 3 over 2. Well, if you guys look back at our table, we've already done that. We did 1/2 divided by rad 3 over 2. And that ended up being rad 3 over 3. So we already did the math here, so literally you could just look at your table for reference. You don't have to do all the math here. I know that the cotangent of 120, again, is 1/2 divided by rad 3 over 2, and I did the math here to figure that out, so it's rad 3 over 3. But the thing I need to take note of is what is negative and what's positive. Well, here I've got one negative and one positive at 120, so that means my answer is going to be negative. So it'll be negative rad 3 over 3. Okay, now let's look at radians. Same thing, just a different unit of measure. Okay, so sine of 2/3 pi. Let's go to our unit circle. 2/3 pi is right here. Again, that's the 120. It's the sine, and sine is just our y value, so that's rad 3 over 2. That one's pretty easy. Rad 3 over 2. And then tangent, we're going to do number 17 now, tangent of pi over 6, so 11/6 pi. Okay, so let's find 11/6 pi. Well, that's over here. And we're looking for the tangent. Okay, so that's going to be the sine over cosine. Well, I already did the math for 1/2 divided by rad 3 over 2. Again, that was done here. 1/2 divided by rad 3 over 2. And I came up with rad 3 over 3. But in this case, the sine is negative, so that, and this one's positive, so my answer is going to be negative rad 3 over 3. So negative rad 3 over 3. And now secant. This will be the last one we look at. Secant of pi over 2. Well, first let's find pi over 2. Actually, let's do a different one, because that's not as helpful. Let's do secant of 7/6 pi. Okay, secant of 7/6 pi. So let's find 7/6. Oh, it's over here at 210. Okay, now secant. Remember, secant, again, is cosine flipped. It's cosine flipped. Okay. So cosine flipped, and we're at 210. That means it's going to be rad 3 over 2 flipped. Rad 3 over 2 flipped, and it's negative. Okay, so whatever we end up with, it's going to be negative. So now, did I already do that? Did I flip rad 3 over 2 already? I think I did. I might have done it in class, but not here. But that's okay. Let's just do it real quick. Okay, and once you've done it once, then you can just do it for all the other ones where you have to flip rad 3 over 2. Okay, so again, it was this, but now we're going to flip it to this. So now it's negative. And we want to get rid of that rad 3 in the bottom. So we multiply top and bottom by rad 3. And now we're going to end up with negative 2 rad 3 over 3. Yeah, we haven't done that one yet. Okay, so there's the secant for 7/6 pi. Okay, that's it.